Now we need to determine the coordinates of the vertex, the focus, equation of the directrix, and the length of the latus rectum of the parabola, whose equation is given by y squared equals to negative 12x. Let us begin. Now clearly, here we have y squared equals to negative 12x. We can compare this particular equation with the standard form of a parabola given by y squared equals to negative 4ax, such that we get 4a equals to 12, which implies the value of a is going to be equals to 3. Now this is a left-facing parabola, meaning let's say we have the axis of symmetry line on which the focus of the parabola and the vertex of the parabola lie. And then we have another point A, which is point A such that V is the midpoint of A and F. And through this point A, we have the directrix line, which is going to be perpendicular to the axis of symmetry line. Now, the negative sign tells us that this particular parabola is going to be left facing. So our goal will be to determine the coordinates of the vertex, the focus, the equation of the directrix, as well as the length of the latus rectum. The length of the latus rectum is defined as the line segment which is passing through the focus and perpendicular to the axis of symmetry with its endpoints at the parabola. Let us suppose that the latus rectum has its endpoints at B and C. So BC is going to be the latus rectum of the parabola. Now, we know that whenever we have a parabola given in its standard form, then the vertex, the coordinates of the vertex of that particular parabola is always going to be at the origin. So that means we can say that this vertex is going to have its coordinate at the origin, meaning our vertex is going to touch the y-axis. So this is going to be the y-axis. Our vertex is going to touch the y-axis. Now, the focus of the parabola is going to be given by negative a comma 0. It's clear that it's going to be negative a because the x coordinate of the focus is lying to the left of the y-axis. So here a value is going to be negative. So negative a comma 0 is going to correspond to the focus of the parabola. Then we need the equation of the directrix. The equation of the directrix is going to be, so we know that any line which is parallel to the x-axis is given by x equals to a. Now, since the directrix line lies to the right side of the y-axis, so a value is going to be positive. So x equals to a is going to be the equation of the directrix line. And then finally, we have the length of the latus rectum. So length of the latus rectum, and we know that the length is always a positive value. That's simply going to be the absolute value of 4 times a. Okay, since we have already obtained the value of a, that's 3. Now that means we can now define the coordinates of the focus. So focus is going to be negative 3 comma 0. The vertex is going to be at 0 comma 0. That's by definition. X is going to be equals to positive a. That means positive 3. And the length of the latus rectum, that's going to be 4 multiplied to 3, and its absolute value, that gives us positive 12. So that's going to be the required values of the given parabola y squared equals to negative 12x.